Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design lambda by 4 microstrip transmission line at 2.4 GHz operating frequency with FR4 substrate. First calculate the microstrip transmission line width and length of lambda by 4 microstrip transmission line using online calculator. So now here I am selecting FR4 substrate and its relative permittivity is 4.4. So I am considering the substrate height is 1.6 mm and operating frequency is 2.4 GHz, 50 ohm transmission line, and for lambda by 4 transmission line the electrical length is 90. Select synthesize. The width is 3.05 mm and length is 17.12 mm. So the width of the lambda by 4 microstrip transmission line is 3.05 mm and length of the lambda by 4 microstrip transmission line is 17.12 mm. And after that calculate the ground plane length and dimensions. Ground plane substrate width and length of the ground plane dimensions. So now the length of the microstrip transmission line is 17.12 and that length I am considering length of the ground plane. Length of the microstrip transmission line is same as that of the length of the ground plane, and width of the ground plane is half of that value, 17.12 by 2. So first save the project. My project name is microstrip transmission line lambda by 4 at 2.4 GHz operating frequency. So my project is successfully saved. So first select the ground plane. First design the ground plane. Select the rectangular sheet. So draw the rectangular sheet in the plane. So this is the width and this is the length of the ground plane. So rename the ground plane GND. Now change the dimensions of the ground plane. So the length of the ground plane is 17.12 mm and width of the ground plane is half of that value, 17.12 by 2, and axis is along the z axis, and position x position is half value of the x size before representing negative sign, that is minus 17.12 by 4, and y position is half of the y size value before representing negative sign, minus 17.12 by 2, and z position is 0 mm. So press the OK button. So this is the ground plane. Next design the substrate. Select the box. So draw the box in the plane. So give the rename box 1 substrate. So change the type of the substrate material, FR4 epoxy. So now change the dimensions of the substrate. See, the length and width of the substrate is same as that of the ground plane dimensions, and y size is length of the substrate is 17.12 and y size is x size is width of the substrate is 17.12 by 2, that is 8.56, and height of the substrate is 1.6 mm. Height of the substrate is 1.6 mm and position is half of the x size value. X position is half of the x size value, so before representing negative sign, minus 8.56 56 by 2, and y position is half of the y size value minus 17.12 by 2, and z position is 0 mm, and this is the ground plane, and this is the substrate. So on the top of the substrate we can design microstrip transmission line. Select the rectangular sheet, draw the rectangular sheet in the plane. So give the rename of this rectangular sheet microstrip transmission line. Change the dimensions of the microstrip transmission line. So the length of the microstrip transmission line is 17.12 mm, and width of the microstrip transmission line is 3.05 mm. Axis is along the z axis, and x position is half of the x size value before representing negative sign minus 3.05 by 2, and y position is and half of the y size before representing negative sign minus 17.12 by 2, and z position is, and that substrate microstrip transmission line is located placed on the top of the substrate, and it's 1.6 mm. So press the OK button, and after designing ground plane, substrate and microstrip transmission line, select the ground plane and substrate, select the ground plane and transmission line, assign perfect electric boundary, and this is the ground plane and this is the microstrip transmission line. Select the microstrip transmission line and ground plane, right click on right click, go to assign boundary, select perfect electric boundary, click OK button. So perfect electric boundary is assigned. And after assigning perfect electric boundary, uh, select XZ plane and draw the port 1, port 2 and assign lumped port excitation port 1 and port 2. Select XZ plane. So rotate the structure, and after rotating the structure, and this is x axis and the z axis. So selecting XZ plane. So select the rectangular sheet. So draw the rectangular sheet in XZ plane. So give the rename of this rectangular one, port 1. So now change the dimensions of the port 1, and width of the microstrip transmission line is 3.05 mm, and height and from ground plane to the top of the substrate, and that jet size is minus 1.6 mm. Axis is along the x-axis, and the position and half of the x size value. Now the x size value is 3.05, and half of that value before representing negative sign minus 3.05 by 2, and y position and length of the substrate is 17.12, and half of that value before representing negative sign minus 17.12 by 2, and position z position is 1.6 mm, that is height of the substrate. So this is the port 1. So now select the port 1, right click on the port 1, go to assign excitation, select lumped port excitation. So click the next button, select the new line. So draw the new line integration from lower port to the upper port. Successfully defined. Click the finish button. So this is the port 1 lumped port excitation. Next, draw the port 2 and assign lumped port excitation. Rotate the structure. Select the rectangular sheet. So draw the rectangular sheet in XZ plane and change the dimensions of this rectangular sheet. So first give the rename of this rectangular one port 2. And change the dimensions of port 2 and width of the microstrip transmission line is 3.05 minus 3.05 mm, and height is jet size is minus 1.6 mm, and position half of the x size, that is 3.05 by 2, and y position is half of the length of the transmission line 17.12 by 2, and Z position is 1.6. So press the OK button. And after draw the port 2, select the port 2, right click on the port 2, go to assign excitation, select lumped port. So click the next button, select the new line and draw the new line integration from lower port to the upper port. Successfully defined. Click the next button, finish. So this is the port 2 successfully assigned. And after assigning the lumped port excitation in XYZ plane, coming back to the XY plane. Next, draw the radiation box. Select the box in the plane. Give the rename of the box 1, radiation box. Change the type of the material. I am selecting the air material. I am selecting air material. Transparency is 0.9. So now change the dimensions of the box. So now here the length of the ground plane is 17 mm, and y size I am considering 2 times of the length of the ground plane. So that is approximate I am considering 34 mm, and x size 17 mm, and the width of the ground plane is 17.12 by 2. So 2 times of 17.12, approximately I am considering 17 mm, and jet size is 17 mm, and the position and half of the x size value before representing negative sign minus 17 by 2 mm minus 34 by 2 mm minus 17 by 2 mm. So click the OK button. So this is the structure of the microstrip lambda by 4 microstrip transmission line. And after that, assign radiation boundary. Select the radiation box, right click on the box, go to assign boundary, select radiation, click the OK button. This is the radiation boundary. Next, set the analysis setup, go to the simulation, select setup, advanced. Now the operating frequency is 2.4 GHz. I am selecting maximum number of passes 12, maximum delta S is 0.02. Select the OK button. This window will appear. Here I am selecting fast sweep type, and minimum frequency is 1 GHz, and maximum frequency is end frequency is 5 GHz and my operating frequency is 2.4 GHz. Maximum number of samples 101. So click the OK button. And after assigning analysis setup, check the validity of the design. Validate. So the design is successfully validated. Now start the simulation. Press analyze all. Simulation is started. So simulation is successfully completed, and after that observe the simulation results: S parameter curve, VSWR curve, Z parameter, port impedance. Select the results, right click on the results, go to create model solution data report, select rectangular plot, select S11, S21, S12, S22, S parameter in decibel, click the new report. So the S parameter plot will be generated. So mark the designated operating frequency 2.4 GHz operating frequency. At 2.4 GHz operating frequency, the return loss value is S11 value is minus 28.76 decibel and S22 is minus 29.27 decibel and S12, S21 and S12 is 0. So this is S21 curve and this is S12 curve and this is S11 curve, this is S22 S parameter curve. Next check the VSWR value. So right click on the results, go to the create model solution data report, select the rectangular plot, select VSWR, click the new report. So this is the VSWR curve. So mark the operating frequency 2.4 GHz operating frequency. So at a 2.4 GHz operating frequency, the VSWR value is 1.07. This is very good value. So the lambda by 4 microstrip transmission line with FR4 substrate at 2.4 GHz operating frequency is successfully designed and simulated. Next, observe the Z parameter plot. Right click on the results, go to create model solution data report, rectangular plot, select Z parameter, select the Z parameter Z11, Z21, Z12, Z22, only magnitude value. So click the new report. So this is the magnitude value of the Z11. So at 2.4 GHz frequency, Z11 is 6.12. So Z21 is 6.12. Sorry, Z21 is 6.12. So Z11 is 6.12. Z21 is 48.6. Z12 is 48.6. Z22 is 6.12. Next, observe the port impedance. Okay. So in the same plot, we can observe the real part and imaginary part. Z parameter, we can observe the real part, imaginary part, and magnitude curve. So click the new report. So this is the center axis, and this is the real part curve. This is the real part curve, and this is magnitude curve, and this is imaginary part curve. So next, observe the far field radiation patterns. So first set the infinite far field setup. Right click on the radiation, go to infinite far field setup, infinite sphere, and pi value is minus 182 plus 180 and theta value is 0 to 360. So click the OK button. So go to the results, right click on the results, create model solution data report, radiation pattern, select the gain in decibel, select a particular frequencies. Here I am selecting minus 90 plus 90, degrees and plus 90. Click the new report. So this is the gain 2D radiation pattern and directivity 2D radiation pattern. Next, observe the 3D polar plot. Go to the results, right click on the results, go to create models, create far fields report, select 3D polar plot, gain in decibel, and directivity in decibel. So this is the 3D polar, directivity polar plot, and this is 3D gain 3D polar plot.